Hello everyone, this is Ali Reza. Before I go forward with implementing the graph and node and their schema, I'm not happy with the names I used for the projects. And before things get more complicated, I want to change them. So common and common.editor, but that's not all I need. I need to close it, but before that, show it in, where is it? File Explorer. As you see, it still says utility and utility editor. Well, we need to close this guy. Yes. And we need to change the names here to common and common.editor. And then I need to open this guy with Notepad++. You see that it's referring to this guy. I need to change it to common and this guy to common.editor and save it. Okay, and the rest is the same. Thankfully, the way Unity handles the stuff is by GUIDs, and because it's the Visual Studio handles the stuff by GUIDs, and those are the only things you need to change. So now if I open my solution, everything should work. Now, there we go. So now I will take out this resource to common. I will make a namespace for node graph, or I could call it graph anyway, and I will move these two from here into the graph, because common.editor.common is a very terrible name for namespacing, and I will delete it. And inside here I will add a namespace called graph, and I will move these two from here into this namespace, and I will remove this common. Sometimes, I'm not sure if it's always, but Visual Studio tends to keep the folder names, so I'm just double checking that I don't have any common here anymore. Okay, cool. Now we can go forward and implement our stuff. So I will start with graph. So graph is a scriptable object. It will have a public string name, and I will call it graph name, because any object in Visual Studio has a name, has a property called name with lowercase n, and I'm not happy with that. So I will just have a graph name, a public, list inside system collection generics of node, and I will call it nodes, and a public node that is called, and this node is actually, let's check it, yeah, it's my node. Okay, cool, active node. Okay, then I will have two, by the way, this guy should be marked as serializable in system, and I will have two non-serialized public node output that we don't have yet as active output, and a non-serialized public node input that we don't have yet, and we call it no, sorry, not node input, a node that we call it connection node. Okay, after that we have a protected virtual void on enable. On enable will be called whenever a scriptable object will be called. Okay, and I'm not sure if I want to keep it virtual or no. So why not make it public? Unenable? No, actually, yeah, protected virtual would be okay. Virtual void unenabled, unenable, sorry. Then we will have a public virtual void initialize and a public void virtual void tick graph. Okay. By the way, for a few episodes we won't be able to go back into Unity and see anything happen because we need to implement tons of stuff before going there. Now, base node is again a serializable class, and we will have public string node name, a public graph, and we call it parent graph, a list, a public list, not that, yeah, come on, behave, list of node output that we don't have, we call it outputs, a public, come on, typed correctly, phew, I can't type, list of node input, and we call it inputs, and a public unique ID, and we call it, and what did I do? Huh, where is this come from? Zamal? No, thank you, I have my own. No, unique ID, let's do it with capital D so that it won't yell at me, and we call it ID, and public list of inline value that we call it metadata. As you see, we have 4 different classes to implement, but it will come later. So we have a constructor without anything. After that, we have a public virtual void, and we call it initialize. We will have a public, well, the rest will come later. So that's that. Now, graph schema is more involved. So it's again a serializable and serializable field, a public node schema, and we call it selected node. Huh, why are you not showing with the correct color? Anyway, so let me copy this guy. I tend to have this serialized field everywhere that I have something because it helps me identify what is getting serialized and what is not getting serialized, like that. So yeah, serialized field of public boolean, and we say it show properties. Another serialized field of rect, and we call it help rect, and it should be public. By the way, the difference between the graph and graph schema and node schema is that graph and node will keep the things that are really needed in runtime only, but the graph schema and node schema are responsible of keeping things for the Unity editor. So for example, when you are working on your graph editor and you are selecting a node, we have it in schema because at runtime the system don't have any node being selected manually by the player or whatever. Show properties is a boolean that we will use to show the properties of the node that is selected when we are finished doing the layout pass on the editor stuff. Help rect is a rect that is corresponding to the the help section of the editor, and you will see why I have it here. And more stuff will come. For example, dark skin, light skin, and then once connection, active output, active input, selection node list. Lots of these guys are just there for, you know, at the editor time when you are tweaking the node graph. And when we are building our game, we don't need this schema to sit inside the game, because that's wasting of space, wasting of memory. So we will put the schemas inside a special folder that will be dropped at the build time on Unity, and basically we will get rid of all these extra space that we are keeping on hard drive and memory at the editor time. And that is why you see very small amount of data on the graph and small data on the node itself. But as we go forward, you will see that the schemas will get bigger and bigger and bigger. Anyway, let's continue. So we have public GUI skin, dark skin. Okay. Public GUI skin, light skin. So that you see that I'm not going for any sort of optimization here, because I don't care, you know. I will drop these things later. I really don't care what's happening here. So I can keep as many things as I need to. So after that, we will have a public, public list of node schema, and that would be nodes inside this schema, okay? Inside the graph schema, I mean. And then we will have a public graph, and we call it related graph. The way I'm handling the connections and the way I'm handling the connection between the schema and the graph, or node schema and node, is that the schema ones will have related graph and corresponding related node, and they will relate themselves to the graph and node when we are working. And for example, if we want to retrieve a graph name, we will say, hey, graph schema, find your related graph, retrieve its graph name. Okay? And for example, you see that here I have a list of node schema for nodes, but here I have a list of node for the nodes. Each node schema will have a related node that refers to its own node, and you will see how the relationship will work in future, but that's the idea here. We are decoupling all the editor stuff from non-editor stuff. So after the graph related graph, we will have a public boolean that is called once connection. This will become handy when we are connecting two nodes to each other. We will flag this guy on the graph, telling the graph that, hey, we are doing some connection between nodes, so do stuff for me. Then we have a public node schema, and we call it connection node. You will remember that the graph itself has a connection node here, and it's non-serialized here. But here we are keeping it serialized because this serialization is different from this serialization. This serialization is happening at runtime by Unity on the scriptable objects in gaming time. This serialization is happening in Unity editor, and editor is handling the serialization. So we will have the serialized here, non-serialized here. Okay? So after that, we will have a serialized field of public node output schema, and we call it active output. A serialized field of public node input schema, and we call it active input. Active output and active input are the input and output on nodes that we are clicking on them when we are connecting a node. For example, we want to connect node A to node B, so we click on it, the node A's output, it will become the active output, and then move my mouse and click on the input on node B, so it will become the active input. Okay? And then we will have a serialized field public list of node schema, and that is selection nodes, selection node, and that is because I want to be able to drag and select multiple nodes and move them around in the editor later. So I have a list here instead of one node. On the other hand, I will have selected node, that is single node schema. When I click on a single node, I will set it as selected node, and I will see its properties, blah blah. But when I marquee drag and select multiple nodes, I won't see any node selected. So I won't see any properties. Then I will have a serialized field of public bool, and I will call it set node. So if I'm setting any node in selection, then I will have some private ones. So private boolean mark drag. If I'm marking the drag for selecting multiple nodes, then I will have a private rect, that is drag rect, and I will have another private rect, that is adjusted drag rect. And you will see what is the meaning of adjusted drag rect later. Now we will come to our methods. Methods. We will have a public virtual void initialize. After that, we will have a public virtual void tick graph. After that, we will have a public virtual void update GUI. Okay? And I'm changing the names here a bit, but it was update graph GUI. I was thinking about draw GUI or whatever, but update GUI is okay. So we have an event and a rect, that is our view rect. After that, we will have a protected virtual void process events, and here we will have an event event and rect view rect. The reason you don't see, I think I know what's going on. The reason you don't see any coloring here, maybe because of ReSharper going derpy, or we will have, because we have some errors. I don't care about it anyway. After process events, we will have a private void draw connections, connection to mouse. This will be triggered when we clicked on an output of a node to connect it to somewhere, and we are moving our mouse around in the work view. Before clicking an input, I want to draw a curve from that output to my mouse position. Okay? Now here it will accept a vector to the position. After that, we will have a public virtual void delete node. This will happen when we are selecting a node and hitting the delete key, and it's a node schema that we're sending in as node schema. Okay, and we want to delete that one, that node. Then we have a private void deselect all nodes. It will, as the name suggests, deselects all the nodes in the graph. And finally, we have a private void get editor scheme. And that's our graph schema for you. Node schema, the last one to stop. We will have a serialized field, and this guy should be, of course, serializable. So a serialized field of public graph schema, and we call it parent graph. Then we have a serialized field of public boolean is selected. So if we selected this node or not, then a public string of comment. Then that means we can put comments on nodes, but of course those are just for editor. Players shouldn't see this comment at all. So public rect, and that is node rect, public rect node boundary, that is the node rect plus the space that is used for input slots and output slots. Then we have a serialized field of public. Now here's the interesting thing, or variable list. It is inside Unity editor internal. Yeah, Unity is not putting it in public, but we can use it. Basically, it's a very fancy way of showing your lists. So we will have a public node, and that is our related node, just like our graph. And then we have a public list of node input schema, and we call it inputs. And it should be a public one. Then we have a serialized field, public list of node output schema, and its output. And then we have some protected, so protected GUI skin, and we call it node skin. A protected boolean show comment, a protected string of help. That's the content for help on the node that we will show in help view. The protected texture to the icon. The icon that we will show inside the editor for the node, if it has any icon. A protected string show name. This is different from the name. The name of the node is something that is being shown in hierarchy view, but the show name is something that we want to show in tooltips, and that's it. So we will have some privates. So private rect view rect, so the view that we are inside it, and private not protected, private read only GUI style, and I will call it, I'm not sure if I will use it, but icon style, and I will say it to new GUI style, empty style there, and I will have a private object, and I will call it connection button. So this will be the output or input connection buttons that I'm using. So for example, if I'm clicking on an output, then I will put that output as the connection button. If I'm clicking on an input, I will put that one as an input, as the connection button anyway. Then, and by the way, there was a reason I separated these guys. They are non-serialized. So non-serialized private vector2, and it's scroll position for scroll views, and non-serialized private boolean is dragging. So if we are dragging the node itself or not. Now we will have an empty constructor. We will have a public virtual void initialize, and we will have few more stuff inside this guy, but I will come to it later because it will inherit an interface from Unity. And by the way, this class is partial because it will become so big that tracking stuff in it would be hard. So I decided to make it partial and break it into different classes, at least different files. So that's it, you know. That's the very base of stuff that we can start with, and it gives us the view of what we need to implement before going any more forward, as you can see. Okay, so yeah, I will stop the video here. It's near half an hour, a good point to stop. And in next episode, I will start implementing these methods, these classes, at least the class names, so that we don't have any errors and we can go forward. Until that episode, have fun everyone. Bye-bye.